Hi guys, it's me and my daughter, apparently, trying to record this second video about reflexes. So what you see here are a couple of GIFs. Oh, I forgot to say that this is Reflexes. This is the Reflexes lecture, coronavirus edition.
That's the coronavirus?
Yeah, that's what it looks like.
Oh, I didn't know that.
Yeah, it is. So we're going to talk about reflexes today. Here's just a couple of examples of them. The one on the right is sort of a real reflex that is a small deer. And you can see that the reflex there is to run out of the way when a crocodile comes out of the water. And the reflexes are very fast, right? You see that deer jump out of the way as soon as she senses movement from inside the water. The one on the left is something that I call the dad reflex. Moms, of course, have this too. This guy can see his child out of his peripheral vision, and as soon as she or he, I can't tell, goes to fall off the bridge, pew, out comes the arm and catches the child. So these GIFs are kind of fun, but they also remind me to remind you guys that reflexes are most often protective to the human body, and they help you stop getting hurt. So human reflex physiology, what is a reflex? Essentially, a reflex is a rapid, predictable, involuntary response that is mostly protective. And mostly we're talking about, okay guys, can you guys, oh, thank you, perfect. This is working from home. Okay, I'm trying to record this lecture, you guys. Go back and play for just a few more minutes. Yeah, mostly we're talking about motor responses to stimuli. So a classic reflex is now shown on the screen, right? This is the patella knee jerk reflex, which is, you go to the doctors, they whack you right below the knee and your leg flies up in the air. And we'll discuss this reflex a little bit more later, but that's the kind of thing that we're talking about. Reflexes can be both somatic, such as the knee-jerk reflex shown on the left, but they can also be visceral or autonomic. So most of the time when we talk about, could you guys stop distracting me, please? Mostly when we talk about reflexes, we're talking about, get out of here, you guys. I'm gonna be done in 10 minutes.
Come on.
Mostly we're talking about somatic reflexes. That's what most people think of. But autonomic reflexes are also really important. So when, for example, your heart, when your blood pressure increases, there is a reflex that you don't even notice. It's totally autonomic, that brings your blood pressure down, right? So if you look on the right here, there are baroreceptors inside your aorta that literally measure the pressure of your blood. And if it gets too high, that can cause damage to your tissues. And so this reflex does not go through your higher brain centers that causes your heart rate to decrease and therefore bring down your blood pressure. So that's the other type of reflex that you can have. Reflexes act through what are called reflex arcs, where there is a detection in the peripheral nervous system to some stimuli. So you step on a tack. That reflex goes through to the central nervous system, but not your brain, just your either spinal column or your brain stem. And then your motor or efferent division of your nervous system carries out the response, lifting up your foot if you step on a piece of Lego, for example. The many examples of reflexes, I'm going to go through a simple stretch reflex arc just to show you a little bit about how it works. Essentially, what happens is, this is an example of somebody holding an empty glass of nothing. If you immediately pour water or liquid, some delicious beverage into that, then obviously it will get heavier and will put some force on your arm and that would cause you to drop that beverage unless there was a reflex that helps you pick up the glass. So when there's force on your arm, it causes stretching in your biceps muscle. That sudden stretching is detected by something called a muscle spindle, which you have in all of your muscles. And that stretching of the muscle is detected, and a signal is sent to your spinal cord. Just want to talk about muscle spindles for a sec, because they're kind of cool. So embedded within your muscle tissue is what is called a muscle spindle, which is this organ on the left of your screen here. And it basically contains some specialized muscle fibers that are surrounded by specialized neurons. And as you can see, these neurons are kind of like a coil around those special muscle fibers. So when they stretch, the nerve is stimulated and sends a signal to your spinal cord. So the muscle spindles detect the stretch, send a signal to the spinal cord. The signal comes in pretty quickly. A motor neurons will fire to contract this muscle, therefore preventing you spilling your beverage. The patellar reflex is a very similar reflex. It's another stretch reflex, and it's what's called a monosynaptic reflex, just like the one we discussed. And I just want to talk about this to explain what that means. So when you actually take a reflex hammer and hit somebody right below the patella, and you can do this to yourself, right? So you cross your legs, so you bring the, or you sit on a table or something, and you use the side of your hand to whack right below your kneecap. Then what you are actually doing is you're whacking this tendon right here that stretches over your knee into your quadriceps muscle. When you hit that tendon, you actually pull on your quadriceps muscle very briefly and stretch it. That causes the muscle spindles in your quadriceps to fire, send a signal to your spinal cord, which then sends a signal back to that muscle to make it contract. And that causes your foot, obviously, to fire up, to fly up into the air. This is another example of a protective reflex. So what is it actually for? Well, if you are just standing still and your knee all of a sudden gives way, then this reflex basically causes your quadriceps to contract, make sure you don't fall down. This is called a monosynaptic reflex because if you look, you actually see that the incoming signal is connected to the outgoing signal. So the sensory neuron is connected to the motor neuron by just a single synapse. So that is why this is called a monosynaptic reflex. Obviously, reflexes are designed to be extremely fast, and that's why monosynaptic reflexes exist, because there's a very short distance to go for the signal, which causes the reflex to happen very quickly. This is a monosynaptic reflex, but it's not quite that simple. There is sometimes an interneuron which can be activated right here. This green thing is an interneuron. If you notice in this particular example, the interneuron links to another neuron which goes to the hamstring. And what that is actually doing is something called reciprocal inhibition. And what that means is when you contract your quadriceps, you want your hamstring to be relaxed so that both your quadriceps and your hamstring don't contract at the same time. And despite the fact that this signaling process, this reflex arc, happens just in your spinal column, there are signals that are sent up your spinal column to your brain so that you know your central processing unit of your brain knows what's going on, right? And the other thing I want to say while we're talking about reflexes is that, you know, they do this stuff kind of thing at the doctor, right? They check your reflexes at the doctor. Why do they do that? It's because reflexes act at different levels along your spine, and you can actually check for nerve injuries to try and see if different reflexes are either absent or present at too much of whether you're too sensitive, basically, to reflexes, because either absent reflexes or hyper reflexes are both indicative of problems with your nervous system. And interestingly, depending on the reflex that you're talking about, it acts at different levels in your spinal cord. So for example, the knee-jerk reflex acts quite low down, close to the site of the reflex itself, whereas reflexes in your arms, for example, connect neurons higher up in your spinal column. Give me 2 minutes and I'll be with you. Almost done. I know, I'm doing something. Give me 1 minute. 1 minute.
Barbie clothes.
Great. I'll be right there.
Okay.
Honey, okay. So you can actually see where you might have some problems in your spinal column by checking which reflexes are either absent or hyperactive. And that's all I wanted to say, because I have Barbie clothes to make, you may have heard. All right, guys, I hope you enjoy the assignment this week, and I hope you're doing well. I miss you guys, and hang in there. Okay, I will talk to you guys next time.